Hi, in this video I'm going to explain how to solve EID Tutorial Topic 3 question number 12. If we read the question, this is a single line diagram, 3-phase distribution board of a small printing factory. So this is a EID electrical installation for a commercial outfit, right? So this will guide us in some decision making. Now if we look at this single line diagram, part 1 wants us to determine the circuit breaker rating of CB1, CB2 and CB3. If you look at these circuits, they are what we call final circuits. Final circuits means at the end of the circuit there is an electrical load. Right, in this case, the 3 circuits are all motor load, M1, M2 and M3, and with different starters involved. So for part 1, if I'm to calculate the circuit breaker rating for CB1, CB2 and CB3, I can list this down into 3 steps. The first step, we have to calculate the full load current. Right, step 1. Full load current, as you remember, we just basically use the power formula. Right, so power formula, if you remember, is I full load is equals to power over the voltage multiplied by power factor multiplied by efficiency. Just remember that the voltage to use, it depends on whether it's 3-phase or single phase. If it's 3-phase, we use √3 times 400 volt, or if it's single phase, we use 230 volt. Step 2, we calculate or determine the design current IB, whether it is same as I full load. If it's non-motor load, it's 2 times if I'm using star delta starter, or 2.5 times I full load if I'm using direct online starter. Then step 3 is just to determine what is a suitable rating here, with the condition that the circuit breaker rating must be greater or equals to IB. Follow this and you should be able to determine the circuit breaker rating of CB1, CB2 and CB3. Right now in the part 2, it says that assuming there is no diversity factor for the load, we are asked to determine the maximum demand of the largest phase. That's the first thing we want, maximum demand. The design current IB for the incoming circuit breaker. In other words, I'm asked to determine what should be the design current here. Alright, and what is the circuit breaker rating for CB6? So as you can see from this single line, this circuit here is a sub-main circuit. So the calculation is slightly different from part 1. Right, part 1 is quite straightforward. So the first thing I need to do is do a load balancing, as there are 3-phase load and single phase load from these 5 circuits. So the good thing, the best thing to do is to come up with a table of the circuits L1, L2 and L3, and try to determine all the load here. So let's say we call this 1, 2, 3, circuit 4, can extend, circuit 5 and circuit 6. Right, you can extend this way as a table, 4, 5, 6. Then we want to know the maximum demand. What is the total maximum demand for this place? So what is the first thing you do is calculate the or rather identify which is the largest motor circuit or largest circuit. So if you look at these three, this one will naturally be the largest circuit. Alright, so to answer part 2, we need to do 2 steps. First step is to do the maximum demand calculation. So step 1, we want the maximum demand calculation. So what we need to do is calculate the I full load of all the circuits. So for example, I have I full load motor circuit 1, right? Now if I use the formula, the 3-phase formula, I should get similar full load current in all the 3 phases. Same thing for circuit number 2, because there are 3 phase, so I full load motor number 2, I full load motor number 2, I full load motor number 2. But for circuit number 3, it's a single phase, so I only need to put it in one phase. So in this case, I will choose L1. Okay, since they are all balanced. Then the remaining 2 circuits, they are fluorescent light and general power circuit. Now, since I'm not given the load balancing, but because they are all single phase, I can only put each one of them in a specific phase. So in this case, for circuit number 4, I will put the load here. This is for fluorescent light, and this one will be the general power, our general power circuit of 12 amps. Whereas for fluorescent light, I can calculate the I full load. I full load is 20 times 36 watt multiplied by 1.8, remember, factor, divide by single phase, because this one is in one phase, L2 phase, sorry, L3 phase. So multiply by, or rather divide by 230 volt, multiply by a diversity factor of 0.9. So this one will be the fluorescent light. And the last circuit is L3, which is 12 amps. So actually I don't need circuit number 6, so we'll take it off. So what I can do now is my maximum demand is actually can do it here. The maximum demand will be the total of the maximum of these 3. If I add up the total of each phase, phase 1, phase 2 and phase 3, very likely the total load highest will be in this phase. So I will take the total maximum demand here as the sum of this phase. Okay, so that is for maximum demand. Now how to calculate IB? Now if you refer to our lecture note, step 2, IB at the sub main is equals to IN, the circuit breaker of the largest load. So in this case, it's IN of M1. In other words, in part 1, we have calculated CB1 rating, right? So this one is actually the CB1 rating plus the I full load of the other phases. So if I'm going to take this as my main phase, so it's just a I full load of M2 plus I full load of M3. Okay, not ICB, not the CB rating. So then finally I will choose the circuit breaker rating. Circuit breaker rating of CB6 must be greater or equals to IB prime. Okay, so this is how I will choose the circuit breaker rating of CB6. Alright, we now look at the third part of this question. For the third part of this question, reads as follows. If the M1 motor starter experiences the L3 phase, that means this starter, okay, this starter encounters some problem and creates a phase to earth fault and draws a forth current of 200 ampere here. This current flowing here is 200 ampere. Now, where does the current come from? The current comes from here, flows through here, this bus bar, and goes here. In other words, CB1 and CB6 will see this high current. So we are asked to determine whether there is proper discrimination between these two circuit breakers. So what is the meaning of discrimination? Discrimination means that the circuit breaker nearest to the fault, let's say if the fault is here, right, we would definitely want to see that this breaker will trip first before this breaker. Alright, so how to determine that? It's very straightforward. It's by comparing the time current characteristic curve of circuit breaker 1 and circuit breaker 6. So we remember that this circuit breaker 1, we determine the circuit breaker rating from part 1, which if you have done it, you will get this answer. And circuit breaker 6 is this one, 63 amps, if you got the correct answer. Right, so all I need to do is go to the time current curve, compare the time it takes for the two circuits, for the two circuit breakers to trip. So I go to the time current curve. Remember, time current curve is time here and current here. I look for the curve for 63 ampere and the 32 ampere, right? And then I trace the 200 ampere line and find what time it takes for both circuit breaker to trip. I would expect the 32 ampere circuit breaker to trip faster than the 63 ampere. So find out these two times. As long as T1 and T2 are different by more than 0.05 seconds, then we have proper discrimination. Okay, so part 3 is actually a very small part. It's quite easy to determine. Alright, that's all for this video. Thank you.